So this next question is another motion graphs question. This one has a displacement time graph and also a velocity time graph. So this question first starts out with some given data in a table and asks us to complete the rest of the table. So we're given the distance for one interval over here, the time for one interval, and the total, kind of a running total of how much time has passed. So to find out how much distance we've traveled in total, or rather how far the object has traveled in total, we're going to look at the distance for one interval, and it's going to be a running total of those. So the first one's pretty easy, 12.36 centimeters. From there, we're going to be adding each one as we go. You might need a calculator to get these, and that's perfectly fine. We'll just keep adding these up. Okay, so we've got our total distance, all our values calculated. Next step is to look at the speed of each interval, and that is in centimeters per second. So each interval has a specific speed. What is it? First one, actually these are going to be relatively easy because we can see the distance traveled in each interval and the time elapsed for one interval. And the fact that our time is 0.1 seconds, that's going to make it easy for us. So the formula to calculate this is to see, okay, we traveled 12.36 centimeters, and we did that in 0.1 seconds. So that equals 123.6. And the units are in the table, so we don't need to write the units here, but centimeters per second. And we'll just keep going down the line. All right, perfect. So we have our total distances calculated and the speed for each interval calculated. Now we can move on to part B, where it asks us to plot the position time graph. So the first step in this will be to assign the x-axis and the y-axis. So always, general rule of thumb, you always put time on the x-axis, and our unit here is seconds. Then what do we put on our y-axis? Well, let's see. We're looking at the position time graph, so that's how much distance we've traveled, and this is cumulative, so we'll be looking at the total distance. So if we look at our highest value, it's going to be 176. So a good method for building graphs like this is to round up your highest value. Here in this case, 200 is a nice number. And then just make sure your increments are even. So go up 50, 100, 150, 200. And obviously 0. So now we can start filling out our graph. I'm going to keep using the orange color so you can clearly see. always start at 0, and then at 0.1 seconds, we're at 12. So knowing that the first tick is about 25, we're going to be half of that. These don't have to be perfect, but you want to be as close as you can, just for accuracy. So 36.6 for our next point. It's just under 50. And for 3 seconds, we are at 72. So this line here is almost 75, so we're going to be just below it. Next point, 0.4 seconds, we're at 118. Just below 125. At 176 for our last point. It's going to be just above 175. Now once we have our dots, we can start sketching this curve. Obviously these sketches won't be perfect, but you're going to do as best you can, make it as straight as possible. And that is part B. Moving on to part C, we want the velocity time graph. So for this one, we're going to be looking at the speed. Speed is another word for velocity. Same thing with the x-axis and the y-axis. X will almost always be time. And for our y-axis, oh, I forgot to label this one here. It's a good lesson to make sure you always label your axis with the units. So displacement, sorry, it's not even meters, it was centimeters. So when we are labeling the y-axis, again, we look at our highest value, round it up to about 600. It's a nice even number that's easy to divide. 300, and then increments between that will be 150. And then remembering to label that, this will be our velocity in centimeters per second. All right, let's start graphing these points. So at 0.1 seconds, we'll be just shy of 150. At 0.2 seconds, we're looking at just shy of 250. So it'll be somewhere around there. Again, doesn't have to be perfect. You don't want to spend too much time trying to measure these out. You can just go with your best estimate, be as accurate as you can. Then moving on to 0.3 seconds, 350 centimeters per second. Somewhere around there. 0.4 seconds, 462. Will be just above the 450 mark. And then final point, 0.5. Just shy of 600. And again, you can see our curve here is actually almost a straight line. So when we're drawing our line, just draw it as straight as you can. Again, it doesn't have to be perfect, but the straighter you can draw, the prettier your graph will be. All right, so that concludes part C. Let's move on to D. Calculate the average velocity of the object. So to calculate average velocity, we got a formula. Velocity average is equal to change in position over change in time. Or position final minus position initial over t final minus t initial. So what are our conditions here? Well, here's our final spot. Time will be 0.5 seconds. And going back to our data, displacement will be 176.04 centimeters. Now let's fill, and then our initial spot will be obviously the 0. So let's fill in our formula. Sorry, I'll try to do this a little neater. And over time, so 0.5 seconds minus 0 seconds. Moving on to the next line. Simplifies because the zeros don't mean anything. If we type that into our calculator, we will get an answer of 352.08 meters per second. That is our average velocity, which is, in case you're wondering, it will be the slope of this line. Now, one more thing, we just want to make sure we're consistent with our significant digits. And if we're looking in the numbers we use to calculate this, we have some numbers that only have 3 significant digits, so it would be best if we can present our final answer in 3 significant digits. I realize this should be centimeters per second. Okay. Final question. Calculate the acceleration of the object. So acceleration, when we want to find the acceleration, we're going to have to be looking at our velocity time graph. And we know that the acceleration will have units of centimeters per second squared. And we have a formula, is the change in velocity over change in time. Or v final minus v initial over t final minus t initial. Now, what values are we going to use here? Well, let's take a look. Our final point and our 0. Time here is 0.5 seconds. If we follow our line across, just taking a look back at our data, 578.4 centimeters per second. We plug those numbers into our formula here. Once again, the zeros go away. And what's nice to pay attention to is our units here. We have centimeters per second over seconds. So that will work out with our desired units of centimeters per second squared. When we plug this into the calculator, we get 1,156.8 centimeters per second squared. That is the correct units. And just before we wrap this up, look at significant digits. These are all 4 significant digits, so when we present our answer, it would be best, again, to keep it to 4 significant digits.